Derivatives of logarithmic and exponential functions. So first, if we have the function ln x, so let's say this is the function and here we have the derivative. So the derivative of ln x is 1 over x. Now ln x is different than log x. You should know this, it's really important. ln x is different than log x. Log can have any number as its base, but in ln x, when you have the base as e, which is the natural base of logarithmic function whose value is 2.71 something, it is an irrational mathematical constant. So if the value of a is e, like if this number is e, then we call it ln, and that is called natural log, and its derivative is 1 over x. But if you have log x, log to the base a of x, then its derivative is 1 over x times ln a. Okay, so that means if you have log to the base e of x, this is actually called natural log. This is called natural log, and when the base is e, we call it ln x. Okay, then we have e raised to x. E raised to x, derivative of e raised to x is just e raised to x, and that is why this is my favorite function. This is the only function whose derivative is equal to the function itself. Okay, now 4 and 5. What about derivative of a raised to x? Now some students, get confused between a raised to x and x raised to a. See, x raised to a is your simple x square, and here you apply the power rule. For x square, what you would do, you would bring the coefficient down and you subtract 1 from the, you bring the exponent down and that becomes the coefficient, and you do minus 1 from the exponent. So this is just 2x, right? So when you have x raised to a, then you bring the exponent down, and in the exponent you do a minus 1. But with a raised to x, its derivative is a raised to x times ln a. So don't get confused between these two. And I think you won't get confused. Just writing in these notations is slightly confusing, but if you'll have like x raised to 5, then I'm sure you'll write it as 5 times x raised to 4 and not the other way around. We have a function, Anika, f of x is equal to 4 raised to x minus 5 times log to the base 9 of x. Okay, we want to find out its derivative. That means we want to find out f prime x. Okay, so here you can see that it's actually subtraction of two functions. This is first function, this is the second function. So Anika, first, with addition and subtraction, it's easy. What's the derivative of 4 raised to x?
4 raised to x times ln times 4?
ln 4, yes, not times 4, we say ln 4. Yeah,
Okay.
so that's the derivative of 4 raised to x minus, now derivative of 5 log to the base of 9x. So if you have any constant term multiplied by the function, like this is a constant term, that constant term will remain as it is. Just write that constant term as it is and then find out the derivative of the rest of the function. Derivative of log to the base
So
9x.
1 over um
Mm.
1 over x ln 4.
ln 9.
I mean, sorry, yes, ln 9.
Yes, right? And you can, so 5 times 1 over x ln 9, or you can multiply this 5. So this becomes 5 over x times ln 9. Okay, Anika? This was
Oh,
okay. Try this one. 3 e raised to x plus 10x cube ln x.
would 3 e to the power of x just stay 3 e to the power of x?
Yes, because you keep the constant term as it is, and then derivative of e raised to x is just e raised to x. So that's 3 e raised to x, and now derivative of this guy. Here you have like three functions. There is 10, there is x cube, there is ln x.
Mm.
Product of three functions. So don't worry about 10. 10 is a constant term. Write your 10 as it is. Now you need to find out the derivative of x cube time ln x. So you'll have to apply the product rule.
Alright, so product rule is f.
So do product rule like this. It will be, you'll be able to do it faster. In your mind, think of this as first function, think of it as second function, just in your mind. Okay, then what you have to do, derivative of first function and keep the second one as it is, plus derivative of second function and keep the first one as it is. That's it. Okay, just a second. Yes, Anika? Did you get the answer?
Um, almost. Would it be like
Hmm.
3x squared times ln x plus x cubed times 1 over x?
Yes. 3x squared times ln x plus x cube times 1 over x. Now you can simplify some terms here. X cube times 1 over x, you can cancel 1x and this becomes 2, right? And then you can multiply this 10 with the terms, like you can distribute this 10 inside, right? Wait,
Yeah.
this is like simple algebra. I'm distributing 10 inside, so this 10 times this term, you have a 3, so it becomes 30 x square ln x plus 10x square. Okay,
Okay.
so whatever you can simplify, we will try to simplify it the most we can. Okay, one final problem here. You'll have to use the question rule. F of x 5 times e raised to x over 3 e raised to x plus 1.
Okay. Wait, so
Hmm.
how would I simplify
You
it
just
completely with the other one?
you just apply the question rule. What's the question rule?
The quotient rule?
Because it's question term.
F,
Hmm.
wait, is it F, prime, wait, F prime of x times g prime of x
Hmm.
minus g prime of x
Hmm.
times f of x over g.
Gx whole square, right?
Okay.
And that is when your
Mhm.
fx is numerator, gx is denominator, right? So again,
Mhm.
when you're doing problems, think of it like this is your first function, and don't do it on the, if you're getting a paper, then you can, with your pencil, you can draw markings like this, that first function, second function, and then your mind just think that the derivative will be derivative of the first function and second function as it is minus derivative of the second function times the first function as it is, and in the denominator you have to write square of the second function. Okay, so you keep this thing in your mind and we write the derivative. So derivative of the first function, Anika, what will be the derivative of 5 e to the power x?
5 to the power of x.
5 e to the power x, and you keep the second function as it is minus derivative of the second function. So what will be the derivative of 3 e to x plus 1?
Would it stay the same?
No, it will not.
Or would it be 3e to x? Like without the 1?
Yes, it will be just 3e to the power x, and then you keep the first function as it is. And in the denominator, square of the second function. So 3e to x plus 1 squared. That's it. Your differentiation part is done. Now you just have to do basic algebra to simplify the terms, right? If you do this part correctly, then your question will be right, like unless you make a mistake, a calculation mistake later. But now you just have to simplify the terms, so you can distribute this inside. So this will be 15 e raised to 2x, exponents will get added, x plus x becomes 2x, plus this times 1 will be 5 e raised to x, minus, what will be this, Anika?
Would that be just 15e2x?
Yes, it will be the same thing, 15 e raised to 2x over, this one you can keep it as it is, 3 e raised to x plus 1 whole square. Okay, and then you see that this term and last term will get cancelled, they are same. This minus this becomes 0, and then your final answer will be 5 e raised to x over 3 e raised to x plus 1 whole square.